So one of the more challenging question for Pythagoras is they can lead you to a quadratic equation. So sometimes the question will be kind enough to tell you that use Pythagoras, but maybe as you progress to upper set, they will not be telling you. So you're expected to apply Pythagoras theorem if you see something like this, where they give you 3 length, and then there is a 90°. So there is a 90°, you still identify your longest length, which is a C. And this can be an A, and then this can be a B. Okay, so how are we going to do that? And how am I going to be doing this and such that it becomes this? So the algebra can be quite complex. So if you want to, you can split them up first. So how do I split them up? So for example, I will do, again, maybe we can start off with the longest length. So the longest is C. So it will be AC squared. You realize this is a bracket square. So this is the one that you will need to use your expansion formula. So either you use your expansion formula or you do a double bracket. Okay, I leave it to your choice. So I'm going to do the expansion formula. Okay. So maybe we can do it for all first. So if you're very scared that you will make careless mistake, so maybe you do one by one before we try to gel them up using Pythagoras theorem. Okay, so this is what I'm trying to do. So if you know that you are the kind who will make careless mistake, maybe then you got to do it part by part. Do it part by part first, and how you're going to show. So using Pythagoras theorem, AB squared plus BC squared is equal to AC squared. So then you take each of them. So you take, okay, I'm going to start with this AB squared. So I'm going to take each of them and put it in. But you make sure that there is no mistake first. So you will have x squared plus 2x plus 1. Oops. Okay. So maybe I do a quick rewrite first. So the working I already shown it just now. So like I say just now, you just work it out separately, make sure no careless mistake. Then we will join them up using our Pythagoras theorem. So it will be AB squared plus BC squared equal to AC squared. So make sure you copy correctly. I think I wrote something wrongly. AC squared. This is a AB squared. Right, so x squared plus 2x plus 1 plus 4x squared plus 4x plus 1 equal to 4x squared plus 12x plus 1 plus 9. So we find it very, very messy. So I will suggest, right, you work on each side first. So I'm going to work on this side. Work on all the x squared on that side, all the x and all the numbers on this side. Then I slowly bring the other ones over. So I'll bring over one by one. So I will get 5x squared minus 4x squared. And I will have 6x minus 12x. And I will have 2 minus 9. You don't have to bring everything over at one shot. You can make it easier first and shift over. So from here, that's how I get my equation. So if there's no careless mistake, most probably you will get the equation. So that's the idea of show that it reduces to this. Okay, so that's an idea that we gotten. Okay, so in any case, during exam, if you do not have the time to, that means you know that you got careless mistake, you couldn't get the equation. So what you can do is jump to part B first, because you can always do the solving first. Do the solving by your factorization. Yeah, factorize, correct. Go and solve it. So there should be two answers when you're solving it. But let's say in the next part, I'm supposed to find the area and the perimeter. So I got to be using the positive value. So I will say something like this: since x is greater than 0, I'm going to be choosing 7. And when I choose 7, my AB will become a 7 plus 1. My BC will become a 2 times 7 plus 1. My AC will become a 2 times 7 plus 3. Okay, so I need some space, so maybe I erase off this part first. Then you find the parameter. So parameter is quite easy, just add them up. Area, you will just do a half times base times height. Okay, so don't make mistake. So this part is a 15. This part is a 8. So it should be half times 8 times 15. So that is one of the kind of question where pythagoras can lead to a quadratic.